In this video, we are going to demonstrate Geomagic DesignX software. DesignX is primarily used as a reverse engineering tool to take 3D scan data and convert it into some kind of CAD model, or even just to clean up the mesh and do things with it. But typically you're going to reverse engineer it to some kind of CAD model. So we'll walk through that process, and we'll talk about some of the different workflows in order to get to a CAD file. Now, DesignX is based on the Parasolid modeling kernel, which is a pretty common modeling kernel. Products like SolidWorks, Siemens NX, Solid Edge, and others use that. And it has a very similar look and feel to SolidWorks. You've got kind of the ribbon bar up here where you've got a lot of your commands. So you click on those, also common in products like Microsoft Office and so forth. But then everything is also in a drop-down menu if you prefer that method. So we'll start with talking about scan data. And so this data could come from really any 3D scanner. And you'll notice typical scan data, it's not perfect. There can be holes in the data. There can be data missing. You can see we don't have the bottom of the part here. You can see we have some data from the table that the part was sitting on when it was scanned. And this part's about 4 inches long and about 2.5, 3 inches wide. But this can be typical scan data. And scan data, if we turn the triangle edges on and you take a close look, scan data is nothing more than polygons, either points or polygons, depending on the scanner. Some output only points, some can convert to a polygon model. But they're basically triangles. It's not intelligent information. Now, this model has been decimated, and what that means is typically the scanner software, and even here in DesignX, has a feature that will create larger triangles in the more flat areas of the part. But then you notice here where you've got some sharp curvature, it'll put more triangles. The only way scan data can define definition and higher fidelity is by having more triangles. So unlike a CAD model, it's very dumb data. There's no smarts to this. It doesn't know this is a plane. It doesn't know this is a cylinder, etc. So that's the downside of scan data, is it cannot really be used in downstream applications very easily because there's no intelligence to it. So what we need to be able to do is turn this into CAD. And the common misconception out there is there's some command or tool that I push a button and I get a CAD file, and that doesn't exist. We're going to walk you through and show you that process. The other misconception out there is that my CAD system can work with this scan data. Most CAD systems do not have tools to be able to work with this and convert it into a CAD model. They can import it, they can look at it, but they can't do anything with it. So we'll walk you through, again, that workflow. Now, starting with the polygon data, I'm going to come here and click on the polygon tab, and I'm just going to walk through what we can edit with this mesh, because one of the advantages of DesignX is I have a whole suite of mesh editing tools you see here. So I can fill holes, I can defeature, excuse me, which is removing a feature. I can decimate, which I've already talked about. I can smooth, I can offset, I can split, I can trim. There's all different things I can do to this mesh file. But the nice thing about DesignX is if I'm building a feature-based solid model, I don't need to do that. I will simply extract the information I need from the scan data and build my solid model, and we'll get to that. So the point here, though, is there's a whole suite of mesh editing tools. We've got other videos that go into those. So let's first talk about the workflow. Now, what I need to be able to do is extract information from this scan data so that I can build a solid model. And again, that's not an automated process. So let's kind of walk through that process. Now, I've already set this part up in a coordinate system, and I've already set my planes up, and that's usually the first thing you do. But for this demo, we've already done that. And there's a whole set of alignment tools under this tab that allow us to do this, which again is another tool you're not going to find in a CAD system. This allows me to align many groups of scan data or a single set and put it in a coordinate system. Okay, so if I go to a top or a side or a different view, you can see we have it in a coordinate system. Okay, so that's the first thing we need to do. We've already done that, and it's a pretty straightforward process. The next thing we want to do is region group this, and I'm going to hit this button and we'll get it started and we'll talk about it. So what region grouping does, because there is no intelligence really here, region group is going to go out and try to make some assumptions about this scan data. So it's going to look for things like planes and cylinders. So if I hold over this, you can see it's a plane. If I hold over this, it's a plane. If you hold here, it's a cylinder. Here it's a freeform shape. Here it's a torus, etc. So what it's just doing is looking at the scan data and basically trying to segment it by color. It's still the same scan data underneath. It's just segmented it, okay? And it's its own separate entity. So if I turn it off, you can see the scan data is there. Now, why is that important? Well, that's going to help us as we start designing our solid model, okay? So first thing we're going to do, let's turn our planes back on. We've already defined a plane here at the bottom. And we're going to want to do what we call a mesh sketch, okay? So we click this. We click the plane that we want to use as our mesh sketch. Now, this mesh sketch is right at the bottom of the part, okay? And because we didn't really scan underneath the part, and scanners really can't scan sharp corners because they're just kind of bombing the part with thousands to millions of points, you're never going to get a sharp corner. So the fact that the plane is right there in the bottom and we're trying to sample that, you can see that that sample is not very good. So what we want to do is move that sample up. So I can move up and down. Now, we got to be careful. We don't want to go up too high if there's draft on the walls and other things. We got to be very careful. So we'll move it up just a very slight amount, and then we'll hit OK. Now the key thing here, though, is the reference sketch, which is what we're creating, is still on that original plane we picked, even though we sampled it up higher in the scan data. So what we get here is this reference sketch. Now this is not really CAD geometry yet in the form of a sketch. It's what we call a reference sketch. Okay. Now one of the nice tools in here is there's a command called auto sketch, and I can just click it, and there's some different options, what resolution and how tight or loose I want to be, and I can slide these around and see different results. And on simple geometry, this does a pretty good job of trying to figure out where lines and arcs should be. So if you look here, you can see it's fit an arc, it's made it tangent to another arc, and down here it's made a nice corner, and so on. So if you have good scan data and your geometry is relatively clean, you can get this auto sketch, and it can work pretty good. Now for our example, I'm going to go ahead and delete that, and we're going to do it more of the manual method, okay? Because a lot of times it doesn't work as well as you'd like. So I'm going to go under here, and I'm going to pick center point arc, and I'm just going to window in on an area that I want it to fit an arc to. Okay, and I can repeat that command. Okay, and I'm going to do it. And you can see I'm purposely avoiding the corners, okay, because I don't want to grab some data that I don't want. It'll skew the results. Now I'm going to create a line. So we're basically fitting CAD geometry in the form of splines, lines, arcs, etc. We're fitting it through that scan data. And I've purposely created a line up here, and I'm going to right click on it, and I'm going to add a horizontal constraint that you see here. So again, very similar to what you would see in your typical CAD software. But so again, what we're doing is sampling the scan data, fitting geometry through it to actually create a sketch. Now the neat thing is as I'm doing that, I can turn on what we call the accuracy analyzer, and I'm turning in this vector multiplier, and that's going to show me how close or far away I am to that scan data. So where the scan data is pretty clean, you can see for the most part we're following that curve, and you see as I highlight along it shows how much we're off, okay, and you can see in what direction. So most of this is very good and very tight. And if you zoomed up on this line, you'd have to go in pretty far, you'll see the pink versus the blue. So that pink is your scan, and the blue is your new CAD you've created. Now, obviously, where I fit the line up here, you can see there's a much larger deviation. But what I'm doing is I'm making a decision that I don't want that to be a curve. Because keep in mind, we are scanning the manufactured part, not the CAD model. We are trying to scan a manufactured part and turn it back into a CAD model. And maybe either I want that to be flat or it should have been flat. And that's the nice thing about this, is I can override it and do what I want. Okay? So I have these pieces of geometry, and now I'm going to fit in some arcs, okay? Some fillets in these areas, and you can see it just kind of snaps to it. And I don't want to fill it down in this corner, I just want a sharp corner. And again, the scanner is never going to get a perfect sharp corner, so we're going to fit a sharp corner there, okay? And again, now I have a closed sketch, and I can turn that deviation back on and I can look at it, okay? And another neat tool is I could come in here and move things around and actually see how it affects how my CAD in this 2D profile compares to the scan data, okay? So at any point I can take a look at that. The other thing I can do is I can dimensionally drive this just like you can any other sketch. So for example, this says 0.8662. My gut would tell me that's supposed to be 0.875, okay? So I can actually override these dimensions and put in an actual amount, okay? So I can fully constrain it with different constraints, dimensions, vertical, parallel, horizontal, tangent, all the normal things that you would do. So once I'm done, I exit that kind of sketch mode, and I've built my first sketch from that scan data. So again, this cannot be done in most CAD systems. So just to review, I created what we call a reference sketch, and then I built an actual sketch from that scan data. So if you turn off the mesh data and you look over here in our tree, just like in any CAD system, this is all history-based or feature modeling. That is my first entity. So there's my scan data, my region group, and then my first CAD entity, which is the sketch. Okay. So let's turn back on our scan data. Now, what I'm going to show next is really one of the really nice things that is more difficult to do without a scanner or without this software. So if you notice, this surface along the top is curved this way, and it's curved this way. So I'd call this a compound surface. Now, trying to measure that and manually, with micrometers and manual tools, trying to build this surface would be extremely difficult, and one of the reasons why you want to use 3D scanning. So if I go under my modeling tab and I do an extrusion and I pick this, the default is a blind extrusion, and we'll get to all of these in a second. So if I just drag this up, let's go to a side view. If I drag this up to the top of the part, and it'll kind of snap to it, I could extrude that as a solid body. Okay. The problem we have is obviously the top is not flat, so doing that is not correct. So I've got a few choices, but the easiest. So let's go ahead and undo that. The easiest thing for me to do, and part of the reason we built these region groups, is now I say extrude. I pick that mesh, and instead of doing a blind, I'm going to go up to what we call a region, and I'm going to pick that gray area, and I'll go ahead and accept it. So what it's done, let's turn off the region group, make it a little easier to see. If you look closely, it is fit. Even though that region was only in this area here, it has enough smarts to try to figure out how to blend it together. Okay, but what we've done is we have fit that to that region. Okay, now let's go back to that accuracy analyzer and turn it back on. This time we're going to do it for the body, not the 2D sketch. And you can set this tolerance range, but you'll notice everything in blue is within the tolerance that I've set. And so you can see what we have here. So green is good. There's our tolerance bar. Red is obviously out, but we've got to cut that away, so I'm not too concerned about that. But you can look at our walls, and again, you can highlight around, and you have to determine what your tolerance, what you can live with. Because again, you're scanning a manufactured part, but you're trying to reverse engineer it back to the perfect CAD model. It's never going to be perfect. But it's certainly well within my tolerance on the top, and right now that's all I care about. But I do notice over here, I'm out quite a bit on this side. The other sides look pretty good, but this side is off. And if I turn off that map and I look, you can see it doesn't fit that area well, because this wall actually has some curvature to it this way. So we're going to do something else here. Okay. So again, there's our extrude. We're going to go back to that sketch, and again, double click it because it's history tree modeling. Let's turn off our scan data, and I'm going to make some changes to our sketch because this back wall has curvature in two directions, so we're not going to be able to extrude that straight up and accomplish what we want, meaning matching that surface. So what I'm going to do is I'm just going to extrude this out, so we basically kind of have the basic shape, but I don't want it cut off back there. And if you know history tree modeling, when you update your sketch, you can see it updates the solid body, which is what we want. Okay, so let's go ahead and hide that for a minute. Let's turn our scan data back on. Let's go back to our region group, and I'm going to go under the surfacing tab, and actually I'm going to do it under the menu, insert, because it's not in that tab, surface, and I want to do what's called a mesh fit surface. I'm going to pick that region, and let me zoom this around, and you can adjust this size of this plane, but that's fine. I'm going to let's do 8 control points in each direction. I'll explain what I'm doing here. Smoothness, I'll leave where it is, and let's take it to the next level. Now here you can tug around these UV lines. I'm not going to. You can also add in more lines here if you want, or even move them around. But again, we'll just leave it for this. But let me explain what this command is doing. So what it's basically doing is creating a surface, and that surface is gonna be at the bounding box I had, which was that plane. But what it's going to do is it's going to suck it right down to that region group. So you can see the curvature there. Because I'm going to use this to trim off the solid body. Okay, so I just need a surface in this case that fits nicely to that region group or that area. I don't care so much what it's doing out here, as long as it doesn't get too crazy. I'm okay with it. And let's turn back on our solid body. Okay. So what we're going to do, it's a fairly common thing in any solid modeling, is we're going to trim a solid to a surface. But again, it's how easily I was able to do that. So let's go back to our modeling command, and we're gonna go ahead and trim up that surface. Okay, so we're going to use the cut command. The tool entity is the solid body, the surface, and the target is the solid body. We're going to tell it which side we want to keep. And now if you turn off the surface, you can see that follows that mesh data, and we can validate that again by turning on that deviation. So now you can notice it fits that very nicely. Okay. So there's just a couple tools right there that if you were not using a 3D scanner, not using a product like this, you would have a really difficult time doing. Now we have data that matches that perfectly. So we can shut that off. Okay, so let's continue on and do some of the trimming on here of some of these other pockets. So let's hide the solid body. Now again, another neat thing is if I turn back on the planes, I can extract a plane, a physical plane, a plane entity like you see here, right from the region group, or I could offset this plane up some amount. But what's nice about Design X is if I come to Mesh Sketch, I can just pick that plane, okay? And it knows that that's a plane entity, and it's going to fit a plane through it. Now the same thing applies here, where we're right at the bottom of this plane, which in that corner, it's a little bit rough. So we'll slide it up just a little bit to get a nice sample. But again, the sketch that we build is going to be down on that plane, so we'll hit OK. Okay, and then again, let's hide our scan data. And I'm going to show kind of a slick tool. So you can see, even in this area, there was a hole in the scan data, but it doesn't matter because we're just using it for reference. So you can kind of do some neat things here. I'm going to use the slot command, and again, I'm only going to window in the area that I want, and then I'm going to pull the slot out because I really don't want the slot to go, or I really don't care what it does out here because it's going to be beyond the solid body. So I could have made 2 lines and a 3-point arc and made it all tangent, but I just took advantage of that slot command. And there's ellipse, you can draw splines, rectangles, all of that. And again, I could dimension this. I can look at how accurate I am to the scan data. So I could come in here and play with this a little bit and try to tighten it up. I can add dimensions, etc. And then let's bring it back here. Let's turn on our solid body. And we'll go back to modeling and we'll extrude. And in this case, I'm going to use the cut modifier, because when I extrude this one up, I actually want to cut away the data of the solid body. Okay, so let's go ahead and do the other slot. So let's bring back on our scan data. That plane's at a different depth. Same thing though. We go to Sketch, Mesh Sketch. We pick the plane. We will slide up just a little bit to get off of that bottom. Let's go ahead and turn off the mesh. Now for this one, let's go ahead and try the auto sketch command again, and we can kind of window in, and you'll see it'll build it, because I don't obviously want to window in on the other data. And if you do, you can always subtract it, like you just saw me do there. Okay. Okay. So makes everything tangent, and it might have missed a spot there. We can always add it. So for example, we're missing that tangency. You simply click the one, double click the next one. We can add that tangency constraint, and now it's fully it has all the parametrics. And maybe this is something we really don't care that much about as far as dimensionally driven. Maybe it just has to look nice. And again, overall, it looks pretty good. We're thousandths of an inch here, so a tenth over here, so still very, very tight. So we'll say, yep, that looks good. And same thing applies as before. Let's turn our solid body back on. We will extrude it, and again, I'll use the same cut modifier. Okay. Okay, so you can see how quickly we've modeled up this. Now let's go ahead and throw some fillets on this part, and because there are some really nice tools for that as well. And again, let's go ahead and turn on our accuracy analyzer for the whole body. Everything's looking pretty good. Obviously, where we have our fillets, we got to do that. So we come under the fillet command, and I'll just select an edge. And it'll do what's called tangent propagation, meaning it's going to look all the way around to see, hey, where does it make sense to put a fillet? Now, the default says 0.05 inches. Now, I don't know if that's right or wrong. I can click this little button here, and it's going to actually look at the underlying mesh, and it's going to figure out the average diameter or radius of this fillet all the way around, and you can see it comes back with 0.0421, and then I could say, well, let's make it 0.04 or whatever I want. So we'll change it slightly to make it an even number, and then we can do constant, variable, phase, full. There's a bunch of different options. Okay, but the nice thing is I don't have to go in and try to manually measure that and try to figure out what it is. I'll let the software do it for me, and then you can see I get a nice fit on there. Okay, so that's what's nice about fillets is you can have it automate it for you. Okay, so let's move on and do the other fillet, and if you notice, this is more of a variable fillet. So again, we can do something very similar. We come under the fillet command, we say variable fillet, go ahead and pick this, and then what we can ask it to do is estimate it for us, and we're going to get this little kind of review there. And then what we can do is come in here and pull this up, and we can have multiple points and have it try to fit that variable fillet for us. Okay, so again, makes it very nice, very fast, and we can check to see how good it fits. Okay, so very easy to do a lot of this more complex geometry. Okay, so next we still have these cylinders in here, and let's use another command. Now we could certainly cut another section and just make 4 circles and extrude them, but just to kind of show some of the commands in here, we can generate solid primitives from some of the geometry. So I'm going to tell it over here it's a sphere, and I'm going to pick it, and you can see it gives me a preview, and I'm gonna build that. Let's turn on our solid body and turn on that so you can see it. And I believe we might be able to do all of these at once. Let's see. Yep, and then go ahead and hit that. Okay, so what I've done, let's turn off our mesh, is I've built those. Now my only concern here is they're right at the top of the part, and now I want to Boolean or cut them away. And they may be, because they're right at the top, it may not like that. So I'm going to come in here under the tools, modeling feature, and I'm going to do what's called move face. And I'm going to pick that, and let's turn our plane on for direction, and sure, I'll take the default, and I can easily repeat the command. There's also a whole macro language in here, so if you did a command over and over, you can automate it. But since we only have a few of these to do, is this faster than just drawing the circles? Probably not, but just to kind of show some of the different tools. The goal here is you can extract or what we're trying to show here is you can extract primitive shapes, cones, cylinders, and things like that right from the scan data. Okay, so there, now I have those, and let's turn the planes off, and now I can do your typical Boolean kind of CAD operation. It'll be these as my tools, and then my target will be that, and we'll go ahead and cut it, and you can see we cut that away. Okay. So if we go back and look at our scan data and turn off our, let's turn off our region groups too, it's just easier to look at. So there's our scan data, there's our solid model, okay, and we rotate it around, looks pretty good. Now again, we can add more fillets on some of these other corners. Let's go ahead and do that real quick. So if we look at our deviation, maybe we're going to fill it up these corners. We'll do that here. Okay, and again we'll check it. So now once we're done, what we now have is a feature-based solid model, whereas with the polygon data, the problem with the polygon data is you can't do anything with it. It's just an STL. If I go to hit file, export, and I pick just the scan data, my options are limited to mesh file formats, STL, OBJ, etc. Okay, can't really use that for downstream applications. Now I have a feature solid model, and if I hit extract and pick this, Now I have formats like IGES, step, parasolid, etc. Okay, so that's what we really want. Now, I have two options here for exporting this this model. One is just to do what I showed, which was step, IGES, and others, parasolid, and that'll now I have planes and cylinders and surfaces, and that'll go out and go to any CAD system, any downstream application. The other option I have, and we'll show here, is what we call live transfer. What this will do, and I don't have SOLIDWORKS on here, but we've got other demos that show this. This will do something a little different, and this works with SOLIDWORKS, Siemens, Creo, AutoCAD Inventor, Solid Edge. What this will do, and you have to have this system on your computer, is it's going to roll this history tree back that we made all the way to the beginning and actually build all of this data in the host CAD system. Okay, so if we were working with SOLIDWORKS, it would roll the tree back, it would make the first sketch, it would extrude it. It literally feature by feature, entity by entity, transfers it into the host CAD system. The advantage of doing that is then you have a CAD model in your host CAD system with the history tree. Now, the live transfer is not perfect depending on what CAD system you're going to, anywhere from 50% with a product like Creo or Pro-E, all the way up to about 85-90% with Siemens, and SOLIDWORKS will go through, same with Solid Edge, because they all use the same parasolid kernel. Inventor works pretty well, AutoCAD works pretty well. So that's another real advantage, is now you get a history tree model in your native CAD system that you can work with. Okay, so just to wrap up, what we did was we took raw scan data. Oops, let's turn off that surface. Raw scan data. We went through the process of building reference sketches, and then either doing extrusions and other operations. We built a feature-based solid model. And there's many other tools in here. There's lofts, there's sweeps, there's revolves, there's all kinds of things, both as surfaces and solids. Okay, so again, most of the same CAD tools you would have in your CAD system, but the ability to quickly extract information from the scan data is really the key part. Okay, so this allows you to design a very complicated model very quickly. I could model this in 10 minutes or less if I wasn't, kind of explaining it. Where if you were trying to manually measure this and then try to build it, it wouldn't be accurate, and it would take a much longer period of time. So why you'd use Design X is to go from that to this and get an intelligent CAD model that is very, very accurate in a very short period of time. So that wraps up this demo of Design X, taking it from some scan data through to a solid model.